This lesson is on complex fractions. Previously, we've been studying how to add and subtract fractions, how to multiply, how to divide fractions, and then we expanded upon that this semester with rational expressions, how to add, subtract, multiply, and divide rational expressions. Well, now, in order to solve complex fractions, we're putting all four of those ideas together. So it's really important that you just take this step by step, but in reality, you already know how to do everything in this lesson. First of all, I want to start with the definition. I want to start with the definition of a complex rational expression. A complex rational expression is an expression, remember that means without an equal sign, an expression that has a rational expression in its numerator and or denominator. So basically what that's saying is that a complex rational expression has a rational expression, which we've been using to add, subtract, multiply, and divide, in the numerator and the denominator, or one or the other. So basically we have to apply more operations than what we're used to in order to solve these. For instance, just to give you an example, one example would be 1 over x divided by 1 over y. That's a complex rational expression. So looking at an example of how to solve these, we have 2 over x plus y divided by 5 over x plus y. I like to write these out horizontally. I think it's easier to see. So we have 2 over x plus y divided by 5 over x plus y. This is a very basic complex rational expression. Now remember, with division we keep the first fraction the same, change the division to multiplication, and change the second fraction to its reciprocal. So we have 2 over x plus y times x plus y over 5. And then to multiply, we just multiply the numerators together, the denominators, and then we cancel out. So these are going to cancel out, and we're left with 2/5. Not too bad, but it is applying different things, and these will get harder. So looking at this example, we have 1 over x plus 3 divided by 4 plus 5 over y. Your first goal, step 1, should always be, actually, what am I kidding? I don't need to write should always be. But it should always be to get numerator and the denominator as one fraction before continuing. So your goal really is to make this into one fraction and this into one fraction before continuing on and dividing. So if we have 1 over x plus 3, 1 over x plus 3 is the same thing as 1 over x plus 3 over 1. So you want to find the common denominator. Well, the least common denominator is going to be x. So in order to do that, I'm going to need to multiply this 3 over 1 by x over x. And that's going to allow us to have 1 over x plus 3x over x. And if you add that, we have 1 plus 3x over x. So now you can see that our numerator is one fraction. Well, now do that with the denominator. So we have 4 plus 5 over y. That's the same thing as 4 over 1 plus 5 over y. Well, the least common denominator, again, is going to be y over y. Or, excuse me, the least common denominator is going to be y. To get that, we need to multiply by y over y. So then we're left with 4y over y plus 5 over y. And now we can add, and we have 4y plus 5 over y. So these are things that we've been working on already. We haven't done anything different. What we've done is we've changed the numerator to be one fraction, and we've changed the denominator to be one fraction. So our original complex fraction has now become 1 plus 3x over x divided by 4y plus 5 over y. So as I said, always get the numerator to be one fraction and the denominator to be one fraction before you continue. Otherwise, it's going to get very complicated. So now we have 1 plus 3x over x divided by 4y plus 5 over y. Hopefully, as you get more practice with this, you're going to start to be able to do this faster and just say 1 plus 3x over x times y over 4y plus 5. So I'll sometimes write out all of this, sometimes I'll just skip to this step. I don't care how you do it as long as you get to this step in the end. And then we have y times this whole thing and x times this whole thing. And that gives us, we'll leave it as our factors, y times 1 plus 3x over x times 4y plus 5. Since we can't simplify any further, this will be your final answer. So I want you to now pause the video and try this problem on your own. Use the same idea as we talked about before. Step 1, get all your numerator and your denominator to be one fraction, and then continue. So pause the video now and try. Alright, so hopefully you've tried this, and the first thing we want to do is get a denominator. The least common denominator is x. So if this was 5 over 1, I'm going to multiply it by x over x. And I'm going to have 3 minus 5x over x. Well, for the denominator, I want this is 4 over 1, least common denominator of x squared. So I'm going to have this divided by 4x squared minus 9 over x squared. Putting that together, we have 3 minus 5x over x times the reciprocal, because that's how we divide, so times x squared over 4x squared minus 9. Well, remember, we always want to factor as far as possible, and we can factor this into 2x plus 3 times 2x minus 3. And that's going to give us, first, simplify, so x squared becomes x, and that x is canceled out. 3 minus 5x has nothing, so x times 3 minus 5x over 2x plus 3 times 2x minus 3. Now, I really don't like to leave 3 minus 5x because I think that throws off being able to simplify things, although I know that I'm not going to be able to simplify anything further. I prefer that you take out a negative. So we have a negative x times 5x minus 3. I just think that's a cleaner way. I'll probably accept either answer, but you should really get into the habit of writing this because it's easier to see if this cancels out with anything down here. So if you got that, nice job. If you didn't, I want you to practice a little bit further before you move on. So this is the last problem we're going to work on, but it's definitely more complicated, so just go with me step by step. It's still the same process though. First of all, we need to get the numerator to be one fraction, and we need to get the denominator to be one fraction. Now remember, always factor first in order to find the least common denominator. So this is going to become x plus 3 times x minus 3. And then we can see that our least common denominator is going to be x plus 3 times x minus 3, which means I need to multiply this fraction by x minus 3 over x minus 3. And that leaves me with 2 times x minus 3 plus 5x over x plus 3 times x minus 3. That's going to be divided by, and now let's do the same thing with the denominator. Now here we have a least common denominator that's not as easy as the top one. So it's going to be x plus 3 times x minus 3, and we're going to have to multiply each fraction by the other factor. So we're going to multiply this one by x minus 3 over x minus 3, and we're going to multiply this one by x plus 3 over x plus 3. And therefore, that's going to give us 4 times x minus 3 plus 2 times x plus 3 all over x plus 3 times x minus 3. Now, let's simplify. I'm going to use the distributive property for all of these. I'm going to have 2x minus 6 plus 5x over x plus 3 times x minus 3. And then because it's division of a fraction, I'm going to keep change, multiply to the reciprocal, which is x plus 3 over x minus 3, all over 4x minus 12, because 4 times negative 3 is negative 12, plus 2x plus 6. Now we can see that x plus 3 and x plus 3 are going to cancel out. X minus 3 and x minus 3 are going to cancel out. And now let's simplify. 2x plus 5x is 7x minus 6 all over 4x plus 2x is 6x. Negative 12 plus 6 is negative 6. Can you factor anything further? Well, even though it's not going to do anything, our final answer can be 7x minus 6 over 6x minus 1. Either answer is acceptable, but this would be your fully factored form. So tomorrow we're going to continue practicing on complex fractions, and then we'll have a quiz on Thursday, a little Quizlet that we'll do in class that will cover all of these operations and complex fractions. See you tomorrow.